discuss this mathematics question. So what you are seeing here is binary operation. If you want to write jam or you are offering further mathematics in school, so you will see it there. So just I want beyond the question I wrote here, I want you to understand the fundamental principle behind binary operation. When you hear about binary, it's talking about two. So you have add binary number in what we call it general math. So has to do with what? A binary number is number or is of 0 and 1, just two numbers, which is 0 and 1. That is involved there. So also this one also, when they talk about binary operation, is talking about a set of number that only have only two elements. That is, if you have a set, maybe you have a set R, then the member of the set R, the element in set R is only two. So that what you refer to as binary. So operation has to do with what? You know, those normal operations of addition, subtraction, multiplication, and like. So that is what we mean by what? Binary operation. Then look at something here. Say an operation, this asterisk, they use something like this, a sign like this one, and an operation can be defined like that. Another thing you can see something like triangle or inverted triangle, or you can see other one can be O and whatever. So anyhow they define the operation. So they will use all those kind of sign or logo for you, so don't be confused. And then an operation, this asterisk is defined or the set X. These are the elements of set X. Now this one is different from the general binary because there's something they want you to do here by the following table. Now what you have here is you have A, B, C, D here, and this one here. Normal, you can equally have it in form of number, as in the modulus. So they can give you the numbers of modulus what 2, have a modulus what 5, 6, 4, and the like. So they can use binary operation to work to resolve it. But here you are given alphabets A to D and A to D. Then here they present you this table. Then they ask you that A is X, that is the member of this element. When they talk about close, that whether a binary operation is closed under a certain operation. So what they are saying is that, look at this. Let's say you have a set of number. This is R, set R, which is 1, 2, 3, 4, 5. So you have this, the element in R is all this. Then they now define a set. Maybe the set they define a set XY, which they call X plus what? Y minus 2. Then they can now give you anything here. So if they say that is 2 and 3 close under this operation, like this one and this asterisk, is this one close under this operation? So what you are going to do is that you solve this one first. So if you solve it, what by how? This X is 2, Y is 3. So if you substitute this one for this, so what are you going to have? You will have 2 plus 3, which is something like this, 2 plus 3 minus 2. So your answer is going to be what? 3. So if they ask you whether this set is close under this operation, so you say is close. Why? Because this 3 here is present here. So that is meaning of the closure, whether it's closed or not. But if the number you get, for instance, if this one is defined as if you define this one as what? 5 and 8. Then they want to ask you whether this set is close under this operation. So as you know that this one is what? Close. Then if you substitute this one into the operation you are given, so what you are going to have is 5 plus 8 minus 2. So if you add this one together, you will get 13 minus 2, which is equal to 11. So is 11 present in the operation in the element you are given? No. It means it's not close. So it's not close under it. So that is what they mean by close or not close. So you can, because you can see it in another aspect rather than this. You can set it like this, then ask whether is close or not. So that is that. So come and look at this one now. Is x close under this operation here? So what we are going to do is that here you look at the element here. Is everything here present here? So that one will determine whether it's close or not. Like A is either plus or multiplication. So this multiplied by this or this plus this give you A. This multiplied by this give you D. This multiplied by this give you D. This multiplied by this give you this. If it is addition, that's how it's going to give you. So anyhow they define it, but these are the results. This is what we have here. These are the elements you have, you are given. So this is the result you get. So in this result, is all this result present here? So you can see A is present, B is present, C is present, D is present. The same thing here, the same thing here, the same thing here. So your answer is going to be what? Yes. So that's yes. You are asked whether the operation is close or not. So your answer is going to be yes. Again, he said that is the operation commutative. Now, here they are talking about commutative. We have commutative law, we have associative law, then we have distributive law. There are more laws than that. We have idempotent law, the Morgan's law, and the like. So what you have here is whether an element, what do you call it, commutative. So you have commutative law. Commutative law. So what does commutative law mean? It means if you have a set of two numbers, A times B, like if you have a set of two numbers, let me say A and B. So how are you going to test whether they are commutative or not? So if A plus B equal to B plus A, so then you will say they are commutative. So if it's under what? Under addition. So A plus B equal to B plus A under addition, so it's commutative. So if you check under multiplication also, this is under addition. So under multiplication also, multiplication. So if you have A times B, does it equal to B times A? If A times B equal to B times A, that's so that they are what? They are commutative. In a simpler way, if you have 2 multiplied by 3 equal to 3 times 2, so it's still 6. Or 2 plus 3 equal to 3 plus 2, which is still 5. So you say they are commutative. But subtraction is not commutative because if you have subtraction, it's not commutative because 2 minus 3 is not equal to 2 minus. It's not the same thing as what? 3 minus 2. So why this one is minus 1, why this one is 1? So you say that this one is subtraction is not commutative. But what about division also? So if you want to check division, 2 divided by 3 is not, this one is not commutative. So it's not the same thing as 2 divided by 3 divided by 2. So that's it. So it's not commutative. So that's it. Then you have associative also. Is similar, like you have the set of 3 number now, A, B, C. So addition is associative. So if you have this one like this, so this associative law, or A plus what? B plus C. So is this one equal to this? So they are equal. So if it is multiplicative, they are equal. But subtraction also and what do you call it is not commutative. So you equally have a distributive law. So distributive law equally like 3 also. Like if you have A, B, C. So when you're talking about distributive, addition can distribute over what? Maybe addition can distribute over multiplication, or multiplication distribute over addition, as the case may be. So if you have A into what? B plus C. So this is this. So you can say that this one is what? AC. So you distribute this one over A, B, B, C over this addition over this. So you can equally do multiplication like that. So that is that. Now, so come back to the question you are given. Is the operation commutative? So here, so what you are going to know is whether they are commutative. Is A multiplied by A equal to A times A equal to A. So look at A times B is this. So if you say B times A, B times A is equal to B. Look here. If you have A times B, it will give you B. So here we have A times B is equal to B. So let's look at B times A. B times A equal to what? B times A is equal to B. So it's commutative. So let's check another one. Let's look at C and B. So we want to look at B times C. B times C equal to what? D. Let's look at D times C. D times C. So D times C. Here you have here we have B times C equal to C. Okay, this is B and C. Okay, C and B. Look at this. C. Here you have C times B. C times B equal to D. So with these two, you can know that the operation is what is commutative. Even if we check another one, take A to D. So A to D is D. So let's check D to A. D to A is D. So it's commutative. So the answer here also is what? Is yes. So is yes. Then what you have here also is say what is the identity element. So what is identity element also? Identity element is an element that if you multiply with another element, it will give you the element. You may not understand the way I'm saying what I'm saying. So look at it here. Let's say you have A and B. So what we mean by identity element? The symbol of identity element is E. So what happens is if you change this one to identity element E. So if you say A multiplied by this element here and you get A back, so it means it is identity element. So if you multiply this element with this element and it gives you A back, so it's what you call identity element. For instance, if you A multiply by 1, it's going to give you what? A. So that's it. So it's going to give you A. Is going to give you A. Now, so you have it like that. Then now coming back to this one. So what is that? What is the identity? What is the identity element? So you want to look at an element that to multiply with another that give you the same element. So that's what we mean by identity element. Like this one now, A multiplied by what? Here is an element that you multiply with another one that give you the same element. So that's what we mean by what? Identity element. So look at this. A times D will give you D. Look here. Remember, how I define identity element is the element that you want to multiply by another one that give you D. So if you multiply D, A with D, or D with A, and it give you D, so that's identity element. So that's it. D is an identity element. A or D here is D multiplied by A. You have D times A. So it give you D. So the identity element here is what? Is A. So that's it. So when the answer that was identity element, so you have the identity element of what? A. A is that because if you multiply A with another element, it will give you that element. So that's what we mean by identity element. So the identity element here is what? A.